Hello, everybody. Today we will go over this fall 2019 Math 241 test 2. Now, as you can see, this test is non-calculator, which means actually this test is doable without calculator. Okay, and the angles we are dealing with will be special angles. Now, it says here that you need to leave your answer in pi if it involves any pi, and do not change to decimal unless I tell you to do so. In fact, write your answer in exact values. Okay, now number one, we will compute and write the exact values of the following three functions of special angles. Okay, and we will show logical steps giving us the answers. Let's start. Okay, sine negative 480 degrees. We have two issues here. The first issue is that this is a negative angle. And the second issue is that this is more than 360 degrees. Okay, you can tackle one of them first and then the other. I think what I will do is I will tackle the negative first. Sine negative is negative sine. Okay, I was actually using this rule here. Sine is an odd function. Sine negative x equals to negative sine x. That's what I use. Okay, and then next, 480 degrees is more than 360 degrees. Now, 480 degrees is coterminal with, you subtract 360, that's coterminal to 120 degrees, right? Okay, so this is equals to negative of sine 120 degrees. Now, 120 degrees is in quadrant 2. Okay, it's in quadrant 2. Sine is positive there. Sine is positive there. Okay, sine is positive in quadrant 2. So this is still positive sine, and the reference angle is 60 degrees for quadrant 2. Okay, and sine 60 degrees is radical 3 over 2. Now that's what I meant by show logical steps leading to the answers. Part B, how about cosine of negative 510 degrees? Now we remember that cosine is an even function. Cosine of negative x equals to cosine x. Cosine negative equals to cosine positive. Therefore, we can write this as simply cosine 510 degrees. Now then, because 510 degrees is more than 360 degrees, then we look for the coterminal angle. If we subtract by 360 degrees, I think we get 150 degrees. Okay, so cosine 510 degrees is the same with cosine 150 degrees, which is in quadrant 2, so cosine is negative, and reference angle for 150 degrees is 30 degrees. So this is the same, negative radical 3 over 2 as well. Okay, next, how about tangent of negative 7 pi over 6? Well, we can use the fact that tangent is an odd function. The tangent negative is negative tangent, just like sine. Okay, so tangent negative 7 pi over 6 is negative of tangent 7 pi over 6. Now, 7 pi over 6 is in quadrant 3. It's more than pi, right? The reference angle is pi over 6. Now, think about it. 7 pi over 6, it is in quadrant 3. It's more than pi, right? Okay, it's in quadrant 3. Now, then the reference angle is 7 pi over 6 subtracted by 7 pi over 6 subtracted by pi. So you cancel this out. That's how you get the reference angle. Okay, if you subtract by pi, then you will get just pi over 6. And tangent pi over 6 is radical 3 over 3. Okay. Next, how about cosecant of negative 5 pi over 6? We start, I don't remember the value for cosecant. What I can do, I deal with the reciprocal first. Okay, so this is 1 over sine of negative 5 pi over 6. And then, oh, sine negative is negative sine. So negative 1 over sine 5 pi over 6. Okay, now sine 5 pi over 6, that's quadrant 2, it's positive, right? Okay, and then the reference angle is pi over 6. Sine pi over 6 is 1/2, so this is negative 2. Okay, now cotangent 615 degrees. This is 1 over tangent 615 degrees. So you see that I convert that to one of the primary three functions first, sine, cosine, or tangent, because those are the one we memorize. Okay, and then because this is more than 360 degrees, let's take a look. What is the coterminal angles? Subtracted by 360, that will be 255 degrees. Is it right? 60. So that is 1 over tangent 255 degrees. I don't think this is a special angle. This is quadrant 3. Okay, this is quadrant 3 where tangent is positive. Okay, so the reference angle is 75 degrees. I think this is the furthest we can go. I don't remember the exact values of tangent 75 degrees until the next test. Actually, we will learn that in chapter 5. Okay, so let's just leave it here. It happens to be not one of the special angles. Okay, how about secant of negative? Oh, let me rewrite that into cosine first. 1 over cosine of negative 2 pi over 3, which is, oh, cosine negative is cosine positive. So this is 1 over cosine 2 pi over 3. Oh, this is quadrant 2. Quadrant 2 cosine is negative, and the reference angle is pi over 3. This is 1 over negative of cosine pi over 3 is 1/2. So this is negative 2. Okay, so you see that we take the negative. If it is more than 360 degrees, then we need to find the coterminal angles. And if the angle is not in quadrant 1, we bring it to quadrant 1. Then from there, we compute the value. Okay, number 2. Let the sector be with central angle 120 degrees. Okay, let's see if you have a sector with 120 degrees. Let's say like this. This is 120 degrees. Okay, and the radius is 7 feet. Now, the first question is find the perimeter of the sector. Now, the perimeter of this sector actually not only the length of arc, please distinguish that, the length of arc plus this side here and this side plus 2 radii. Okay, now what we will do first is to compute the arc length. But for us to compute the arc length, we need to find the central angle in radian. Okay, so the central angle is 120 degrees, but it has to be in radian though. Okay, so 120 degrees multiplied by pi over 180 degrees, that would be 2 pi over 3. That's the central angle in radian. Now then, the arc length is equals to the central angle in radian times the radius. Okay, so 2 pi over 3 times 7 feet. That is 14 pi over 3 feet. Okay, this is the arc length here. Now, the perimeter, however, equals to, in this case, is the arc length plus twice the radius. Okay, so 14 pi over 3 plus 2 times 7. Okay, so that's 14 pi over 3 plus 14 feet. Okay, now you can just leave it like that. If you want to do the LCD, then 14 times 3, that will be 42. So 14 pi plus 42 over 3 feet. Now, if you want to have a common denominator. Okay, but I will be happy enough if you can finish here. Now, how about the area of that sector? So what is the area here? What is the area covered by that perimeter? Well, the area of a sector is 1/2 theta r squared, right? The theta has to be in radian, don't forget that. Okay, so 1/2 times 2 pi over 3 times 7 squared. That's cancel the 2, that's 49 pi over 3 square feet. That's the area of the sector. Number 3, a tire rolls with at the rate of 100 RPM. So that's the angular velocity, 100 RPM. Oh, by the way, that RPM stands for revolution per minute, not radian per minute. Okay, that's revolution per minute. So in radian, this will be 100 times 2 pi radian per minute. Okay, which is the 200 pi radian per minute. Okay, now then the radius is 45 centimeter. The question is, find the distance traveled by the tire if it moves for 1.5 hours. Now the time is 1.5 hours, or in minutes is, that's 1.5 times 60 minutes, that's 90 minutes. Okay, so the linear velocity will be the angular velocity times the radius. Okay, so that's 200 pi times 45 centimeter. That will be 90 plus 2 zeros pi centimeter. Actually, this is per minute. Which is 90 pi meter plus per minute. Now then, what is the total distance traveled? The total distance traveled S is equals to the linear velocity times time. We can also see that the formula here actually coming from the linear velocity equals to the distance traveled over the time. Okay, I multiply both sides by t, that gives me the distance traveled. So this will be 90 pi meter plus per minute times 90 minutes. Okay, that will give me 81 with 2 zeros pi meter. That's actually pretty far, huh? That's actually equals to 8.1 pi kilometer. You can just leave your answer in meter if you want, that's okay. Or even in centimeter, but of course that's in centimeter, the number will be a lot larger. Okay, Let's go on to the next page. Oh, this is a good question here. Okay, for this number 4, consider circles in a bicycle. Suppose the radius of the chain ring is 8 centimeter. So the chain ring, actually this one here, 8 centimeter. That's the radius. Of the sprocket, 3 centimeter. So the sprocket here, the radius is 3 centimeter. Okay, and the rear wheel, let me use different color. This one, the rear wheel, the radius is 45 centimeter. Let the cyclist be pedaling at, we should be pedaling at 50 RPM. So that's the chain ring, right? Okay, so the omega, the angular velocity of the chain ring is 50 RPM. Oh, actually, that's what we need here. The omega for the chain ring, angular velocity of the chain ring is 50 RPM. Oh, but this is not in radian, right? We need to change it to radian, multiply by 2 pi. This is radian per minute. That gives us 100 pi radian per minute. Now, how about the linear velocity of the chain ring? Now, the linear velocity of the chain ring will be the angular velocity times the radius of that chain ring, okay, which is 100 pi times the radius 8 centimeter. So the linear velocity will be 800 pi centimeter per minute. The main story is we try to translate the speed of the cyclist pedaling here and how it translates into the linear speed of the bicycle. Okay, from how fast you cycling, the angular velocity translates into how fast you actually cycling. Okay, now you see that the chain ring here has the same linear velocity with the sprocket. Okay, why? Because it is connected by the chain. Okay, so if this chain ring here travels for like 800 pi centimeter per minute, that should be the speed of the sprocket too. Okay, the linear velocity of the sprocket. So part C, find the linear velocity of the sprocket. Well, the linear velocity of the sprocket is the same to the linear velocity of the chain ring, which is 800 pi centimeter per minute. Now, even though they have the same linear velocity, the angular velocity of the sprocket will be different, right? In fact, the angular velocity of the sprocket is equal to the linear velocity divided by the radius of that sprocket. In this case, that's 800 pi divided by the radius 3. Now, this will give us radian per minute. Now, then the speed, how fast this sprocket's turning is actually the same with the speed this real wheel turning. The angular velocity will be the same. In other words, if the sprocket turns like 1 time, then the real wheel will also turn 1 time. Okay, now, this way, then the angular velocity of the real wheel will be the same to the angular velocity of the sprocket, which is as we see from part D, that is actually 800 pi over 3 radian per Now then, with that kind of angular velocity for the rear wheel, then what is the linear velocity of the rear wheel? That is the angular velocity times the radius of the rear wheel. That's 800 pi over 3 times 45 centimeter. Now, this will give us centimeter per minute. Okay, 45 cancels 3, 15. 15 times 8 is 120. If we convert this to meter, that will be 120 pi meter per meter. Okay. You can just leave it in centimeter per minute if you want. Okay, but you know, like we usually measure speed either in meter per minute, kilometer per hour, or miles per hour, like that, right? Okay, but I'm happy enough if you can go to here, for example. Okay, go on with number 5. We have these trig functions y equals to 2 minus 3 cosine 4x plus pi. Oh, when you see this, always factor the coefficient of the angle first. Why? So that we can see the phase shift. If I factor the 4 out, I get pi over 4 inside the parentheses, right? Now, then from here we see, oh, what is the center? The center is 2. The center is 2. Let me color code that so that you can see. The amplitude is the absolute of -3, which is 3. Now, that -3 comes from here. Okay. Now, then how about the range? Well, the center is 2. The amplitude is 3, means you go up 3 units, you get 5. Go down 3 units, you get -1. That way, then the range will be from -1 to 5. Okay. Now then, how about the period? The period equals to 2 pi divided by the coefficient of the angle. 2 pi divided by 4, that's pi over 2. Now, how about the phase shift? The phase shift is how far you move that to the left or to the right. To the left, then we use negative. Now, in this case, the phase shift is negative pi over 4 because we shift that pi over 4 units to the left. Okay, pi over 4 units to the left. So how about the y-intercept? This you may say, oh, Thomas, we never really see this, but the y-intercept, basically you set the x equals to 0. I hope you remember that, right? So when you set the x equals to 0, you get 2 minus 3 cosine pi. Now cosine pi is -1. So this is 2 plus 3, which is 5. So the y-intercept is 0. Okay. The phase shift, let's go to this graph here. The phase shift is negative pi over 4. That's where we start. Okay, and then the period is pi over 2. Means from here, negative pi over 4, we add pi over 2. Then that one cycle we finish at, well, in this case will be pi over 4 also. Okay, let's see. Negative pi over 2 plus pi over 4 plus pi over 2. We do the LCD. We get that pi over 4, right? So that's where the one cycle ends. Now, if you want to compute the quadrantal period, if we compute the quadrantal period, take that period, the quadrantal period is equals to the period divided by 4. So pi over 2 divided by 4, that's pi over 8. So if you add pi over 8 here, you get negative pi over 8. Just do the math, okay? This is pi. So that's what the what we call it, the partition. Okay, now, and then we see this is negative cosine, right? So the graph actually starts from the bottom, use red color, from the bottom here, goes to the middle, goes up here, here. Okay, now make sure you don't make them too straight though. It has to be curved. Okay, in my lecture, I already asked you to do to sketch the graph, right? So you know it's curved. It's not like this. It's not like this. It's not like, oh, it's from here to here and then from here to here. You see that it becomes really straight? No, not supposed to be. Okay, not supposed to be. So that's for number 5. Let's go on to the next page. Number 6. Let's factor the coefficient of the angle pi. So this will be 3 minus 2 cosine. Factor the pi out, x minus 1/3. So the center is 3. The amplitude is absolute of -2, which is 2. So the center is 3, up 2 is 5, down 2 is 1. So the range will be from 1 to 5. The period will be 2 pi over coefficient of the angle pi. The period is 2. The phase shift is positive 1/3 because we shifted to the right 1/3 units. And the y-intercept is when the x equals to 0. So y equals to 3 minus 2 cosine -pi/3. This is 3 minus 2 cosine, or cosine negative is cosine positive pi/3. Now cosine pi/3 is 1/2. So 2 times 1/2 is 1. This is 2. The y-intercept is 0, 2. Okay, the phase shift is 1/3. The period is 2, so when from 1/3 I add 2, this will be 2 plus 1/3 is 6/3 plus 1/3, that's 7/3. Okay, and then the quadrantal angle is 2 divided by 4, that's 1/2. Okay, or you can do the midpoint, like 1 and 7, the midpoint is 4/3, right? 1 and 4, that will be 5/6. This is 11/6. Okay, negative cosine, so the graph will be from down here, go up. Oh, the same to the previous one, huh? The previous one also negative cosine. Okay, so that's the graph of this y equals 3 minus 2 cosine of pi x minus pi/3. Okay, that's for number 6. Let's take a look on number 7. Oh, this is on inverse trig function. Now, what you really need to remember here is the idea of restricted domain. Okay, let's start anyway, just to remind ourselves now. And to answer this question, what is cosine inverse of -1? Then you need to answer like cosine what angle equals to -1, and the restricted domain for cosine, to make it 1 to 1, the theta has to be between 0 to pi, quadrant 1 and quadrant 2. Now, cosine what angle give us -1, and the answer is pi. Okay, now the answer for cosine inverse supposed to be in radian, but sometimes I have students answer me in degrees. For your level right now, I will accept that, but supposed to be, the answer supposed to be in radian. Okay, I think I want to say this one, this way. This is okay, but technically speaking, the answer is supposed to be in radian. Now, how about tangent inverse of -radical 3? Now, then you need to ask yourself, tangent what angle equals to negative radical 3? And don't forget, the restricted angle for tangent inverse is from negative pi over 2 to pi over 2. Okay, we can actually use the fact that tangent inverse is an odd function, just like tangent is an odd function. So tangent inverse of negative equals to negative of tangent inverse. I think that is actually better, right? Now tangent inverse of radical 3 is pi of 3. Okay, so in total, the answer for this is negative pi over 3. Okay, now how about tangent inverse of tangent 150 degrees? Now, notice that this is not 150 degrees. Why? Because tangent inverse and tangent, they only cancels if the angle is in quadrant 1 or quadrant -1. Now, 150 degrees is not in quadrant 1, nor it is in quadrant -1. So, how do we answer this? Just do it inside out. Just do it inside out. This is equals to then tangent inverse of tangent in quadrant 2. That's negative tangent of reference angle 30 degrees, right? So this is equals to negative of tangent inverse. You know what? Let me do it slowly. So this is tangent inverse of negative tangent 30 degrees is radical 3 over 3, right? Now tangent inverse of negative is negative of tangent inverse of radical 3 over 3, which is negative of pi over 6. Okay. Now, how about sine inverse of sine? Same thing. You see that this is in quadrant 2, which is not in the restricted domain. So let's do it inside out. Sine inverse of sine 5 pi over 3. Actually, 5 pi over 3 is in quadrant. That's actually quadrant 3, right? The reference angle is 2 pi over 3. And because it is quadrant 3, it's negative. No, I'm sorry. That's quadrant 4. What am I doing? What am I doing? I'm sorry. That's quadrant 4. Well, sine's still negative in quadrant 4, but the reference angle is pi over 3. Okay, so sine inverse of negative sine pi over 3 is radical 3 over 2. This is negative sine inverse of radical 3 over 2, which is negative pi over 3. Okay, number 8. I like this kind of question. You see that I always ask this question. What is cosine of tangent inverse of 4 over 3? The way you do this problem is, let's call this angle theta first. Let's call that angle theta first. Okay, and apparently because 4 over 3 is positive, so tangent inverse 4 over 3 is in quadrant 1. It means the theta is an acute angle. Okay, theta is an acute angle. Therefore, we can draw the right triangle. Actually, that's the secret of this method. Okay, suppose this is theta, this is 4, 3. That's tangent theta is 4 over 3. By Pythagorean theorem, this is a Pythagorean special Pythagorean triplet. This is 5, right? So cosine of theta is 3/5, right? From the triangle. Now, why we do cosine theta? Because theta is tangent inverse of 4 over 3. Okay, so cosine of tangent inverse of 4 over 3 is 3 over 4. Okay, that's how we do it. Okay, now using the same concept, what happens if we have cotangent of sine inverse x? Call this theta first. Okay, let theta be sine inverse of x. Now we have x is positive, means sine inverse of x, that angle is in quadrant 1, right? Therefore, sine theta equals to x, from which we can draw the right triangle. If this is theta, the sine is x, which is x over 1, opposite over hypotenuse. Now, the adjacent, therefore, by Pythagorean theorem, this is square root of 1 minus x squared. Then what is cotangent of theta? That's adjacent over opposite, right? Now, why we do cotangent theta? Because the theta is sine inverse of x. Okay, now what I do here is very, very important for your calculus 2 later on. Okay, so remember this technique very, very well. Okay, that's for number 8. Let's go on. Now proving. Now remember, when it comes to proving in my class, I need you to first show the direction of the proof. In this case, I think it's easier for us to prove from left to right. And then you write, because we start from left, LHS. So left-hand side, and then copy down the statement you have on the left-hand side. No, don't do any modification, just copy that down. Okay, this is what we have on the left-hand side, right? This is what we have on the left-hand side. Now, then the next step, which we will do in the next line, then you think about, oh, what can I do going on from here? Okay, let's see. You know what? Tangent is, let me change it into sine cosine thingy. So sine squared x over cosine squared x minus sine squared x, right? And then let's do LCD. So sine squared x over cosine squared x. I basically keep the first term. The second term, I do LCD cosine squared x. So I multiply the top and the bottom by cosine squared x. That way, we can put things together under the same fraction. Right? For the numerator, we get sine squared x minus sine squared x cosine squared x. Okay, and then, oh, on the numerator, we have sine squared x as a common factor. Oh, you know what? You see that we need tangent squared x and then sine squared x, right? Times sine squared. This is our sine squared x here, and this is our tangent. You see it? You see that? Okay, so we are actually very close already. Let's execute this. This is sine squared x over cosine squared x times sine squared x. You see the way I write it? Okay, which is equal to, let me go here, which is equals to tangent squared x times sine squared x, which is our right hand side, and therefore that's the end of the proof. Okay, now that's for number 9. Number 10. Yeah, apparently the left hand side is more complicated. You know what, let me start from the left, further left, in case I don't have enough space. So left hand side equals to cosecant x plus cotangent x over tangent x plus sine x. Too many trig functions here. Let me rewrite them into sine cosine. So 1 over sine x plus cotangent x becomes cosine x over sine x. Tangent x becomes sine x over cosine x. plus sine x. Now the LCD is sine x cosine x. So on the top, I multiply by sine x cosine x. The bottom also multiply by sine x cosine x. So we basically multiply by 1, right? Which should not change the value. Now then, on the top left, 1 over sine x multiplied by sine x cosine x will give us cosine x, right? The sine x cancel. Plus the top right, cosine x over sine x multiplied by sine x cosine x. The sine x cancel. We get cosine squared x. At the bottom, we have sine x over cosine x multiplied by sine x cosine x. Cosine x cancels, so we get sine squared x. And then sine x times sine x cosine x, that's sine squared x cosine x. One of the very common question when we do proving is Thomas, how do we know that's what we need to do? Well, like for this one here, we have too many trig functions, right? And one of the rule of thumb is if you deal with too many trig functions at once, you may want to consider converting them to sine cosine first. Okay, now next, when we have this situation, what do we do? How do we know that we will multiply by LCD? Well, actually, we don't know we should multiply by LCD. If you think about it, it's more about the fact that it is a complex fractions, right? So now nobody wants to deal with complex fractions. You want to simplify that first. And one of the way to simplify complex fractions is to multiply the numerator and the denominator by the overall LCD. Okay, that's how we know. It's not that we know it right away. You write it down first, then you will see, oh, you know what I can do here. Okay. Now sometimes you have some options. I can do this, I can do that. Then based on your experience, then you need to have a lot of practice, right? But with practice, you will see what you can do, right? Okay. But there are times, for example, in our last step here, you may wonder, then what should I do from here, Thomas? Now, instead of thinking about like, what are the options, think about one thing you can do. So this is not the case where you have many options. Instead of thinking like, what are the options we can do and which is the best one, think about what you can do first. In other words, there are times in our life, okay, we don't have any option but one thing, okay, and that's actually the good hint of what you should do next. Okay, so many times we don't have good choices, like whatever things we do, we have bad consequence, right? But like for you to do, for example, in this case, I factor the cosine x on the numerator. Why do I factor cosine x on the numerator? Well, because that's the only thing I can do from there, if you think about it, right? And on the denominator, notice that we can factor sine square x, so because that's the only thing we can do also, right? Okay, and then from here you see, oh yeah, 1 plus cosine x cancels, right? And we need to get this cotangent times cosecant. Now cotangent is cosine over sine, right? And then you have another extra sine x on the denominator after that. Okay, so let's cancel this first. Let's cancel 1 plus cosine x such that we have cosine x over sine x times 1 over sine x. That's how I rewrite that cosine x over sine square x, which will give us cotangent x in the first factor and then cosecant x in the second factor. That is what we have on the right hand side, right? You see that? This is our right hand side and a proof. Okay, now let's go on. The last question, still proving. Number 11, proof. Again, from left hand side seems to be more complicated. Side, tangent x plus tangent, oh, we have two variables now, tangent x plus tangent y over cotangent x plus cotangent y. Oh, Thomas, I never see problem with two variables like this, proving with two variables. Well, there must be first time for everything, right? But you need to trust me that the way I teach you already enough. The foundation is already enough for you to do these problems. Okay. We have tangent x, tangent y, and the other one is cotangent x, cotangent y. I think let's do the tangent x, tangent y. So I leave this in tangent x and tangent y here. Now on the denominator, I get 1 over tangent x. That's for cotangent x. And cotangent y is the reciprocal of tangent y. Like this, right? Now notice that now we have complex fractions again. Then what is the next logical step to do? Well, multiply by the LCD, which is tangent x, tangent y. Okay, now doing so, we have on the top, we get, actually on the top, I don't want to multiply that in, just leave it like that. So this is tangent x plus tangent y times tangent x, tangent y. If you want to distribute that in, that's okay, but I will just leave it like that. Now, on the denominator, on the other hand, this guy multiplied by tangent x, tangent y will give us the tangent x cancel, right? So we get only tangent y plus the second term when we multiply 1 over tangent y times tangent x, tangent y. You see tangent y cancels, right? And we therefore have only tangent x. To our surprise, notice that this guy here is actually the same terms with this by commutative. Okay, therefore they cancels and we get tangent x, tangent y, as we have seen on our right hand side. And that is the end of the proof. Okay, so this is the solutions for fall 2019 Math 241 test 2. Notice that this test is doable without calculator. Okay, that's for this one.